Hi, pre-calculus. This lesson is on section 2.2, and we are going to be learning about polynomial functions of higher degree. This section would be the start of almost the rest of this chapter 2. So the first thing I'm going to do is I'm going to talk about graphs where y equals x to the n, and n is an even number. So let's see, I could talk about x squared. And if x is an even number and I put in 0 for x, I'm going to get out 0 for y. If I put in 1 for x and I square it, I'm going to get 1 out for y. If I put in -1 for x, I'm going to get a +1 out for y. When we do even powers, the negatives that you plug in will turn into positives. And this is, excuse me, this is a parabola, and we're only going to see just a little bit of it. And this is an approximation also, not perfect. Now, the next one we're going to talk about is x to the fourth. Now, with x to the fourth, if I plug in 0 for x, I get 0 out as well. If I plug in 1 for x, I also get 1 out. If I plug in -1 for x, I still get 1. But these are not the same graphs. What's going to happen is as we plug in small, tiny fractions, this is going to be closer to 0. And then all of a sudden, at 1, it's going to rise up faster than the x squared did. So it's going to kind of have like a flatter bottom. But then at 1, it's going to rise up faster. And then x to the 6. If I plug in 0 for x, I get 0 out for y. If I plug in 1 for x, I get 1 out for y. If I plug in -1 in for x, I get -1 out for y. So again, these 3 points are repetitive, but for x to the 6, it's going to be even wider at the bottom, and then it's going to rise up even faster. And what I'm drawing is like a very approximated drawing. It's not going to go straight up. That last line that I drew kind of looks like it goes straight up. Shouldn't look like it goes straight up, but it should look more flat in the middle. Oh, shoot, what happened here? My stylus erased something. It should look more flat in the middle and then rise up faster past 1. Okay. And then we're going to look at odd graphs. So the first odd graph that I'm going to start with is just x. So y equals x. That's every ordered pair where you plug in x, you get out the exact same y. So 0, 0, 1, 1, 2, 2, -1, -1, -2, -2, and so on. That's a line. I'm going to use my line. I haven't used that for a while. Line. There we go. Now we'll try y equals x to the third. So if I plug in 0 for x, I get 0. If I plug in 1 for x, I get 1. But if I plug in -1 for x, y is also -1. So a cubic graph looks like this. And it has this kind of squiggle in the middle where it was going concave down to where it's going concave up. It changes right in the middle. This point has a vocabulary term. It's called the point of inflection. And that's the point where the concavity changes from down to up. Now I'm going to go up one more power. We'll do y equals x to the fifth. And if I plug in 0 for x, I'm going to get 0 out for y. If I plug in 1 for x, I'm going to get 1 out for y. If I plug in -1 for x, I still get -1 out. So we're going to have a similar situation that we did in the evens. It's going to start wider, but then it's going to shoot up faster past that 1. It's going to start wider, then it's going to go down faster past that 1. And this, again, is an approximation of the graph. This is not perfect, but this is just giving you an idea of how they do have points in common, this section where the concavity changes will start to flatten as the powers get higher. Now, the next thing we talk about is end behavior, and this is something you should have learned in Algebra 2. And we've got 4 different scenarios. 2 of them I was looking at right here. I just wasn't talking about end behavior. So my first scenario is our degree is even and the leading coefficient is positive. So I'm going to think about a graph being something like y equals positive x squared. Okay, it can be any degree that's even. So I'm using an x squared because I'm familiar with that. And then the coefficient is positive, and here it's just a positive 1. And I know that this graph looks like this, or it's opening up in both directions. But this is going to be for any even. This is not just squared. So what's happening in the center, we're not 100% sure. But what we do know is for every single even graph that has a positive coefficient, the very ends of it will be opening up. This will happen every single time. So what's happening in the middle? I don't know. Some question marks going on in the middle. It could be like, and this is what we're going to get to. We're going to get to graphs that's supposed to be rounded. We're going to get to great, crazy looking graphs that look like that. That's what we're starting to do. But just for right now, we're looking at the end behavior without graphing anything. If the degree is odd and the leading coefficient is positive, so an odd leading coefficient of positive, that starts to make me think about just a line. Y equals x or y equals 2x. A line, whoa, that was a terrible perpendicular graph. If I'm making a line, let's see, say 2x plus 1, so this isn't just straight through 0, 0. There we go, something like this, okay? And when I talk about the end behavior, I'm talking about what's happening at the very ends of it. And this is going to be the same for every single odd degree with leading coefficient that is positive. Our ends are going to end in opposite quadrants. If I'm reading from left to right, the way I always read, from left to right, it will go from down to up. Now I'm going to fill something out in these big spaces, but I'm going to come back to that. So the next one, if the degree is even and the leading coefficient is negative. So we're going to have, I'm thinking a parabola that opens down, but it's not always a parabola. So I don't know what's going on in the inside of this. I'm going to erase this. I don't know what's going on the inside. All I know that the ends are going to be pointed down. And then if the degree is odd and leading coefficient is negative, we're going to take this one here and we're going to reflect it in the x-axis. So we will have a graph that starts from high to low. And again, what's happening in the center, nobody knows until I have an equation. Now what we're going to do is we're going to write the symbols of how you describe end behavior. And we're going to use these symbols because they become more and more important as you get on to higher level math. So I know I taught them in my Algebra 2, but some teachers may have skipped the symbols. So you do need to learn these. And they aren't hard once you've practiced them a couple times. First thing we're going to talk about is f of x. Maybe I should make like a little key up here. Where can I do it? Let me do it right in here. If I'm talking about f of x, that means the y. That means the up or down. If I'm talking about x, well, that means x, which is the left or right. When you see this is going to mean approaches. Approaches. It's an arrow. It's always going to be facing the same way, and it means approaches. And then we will have one of these guys. Whoa, that was bad. I don't like drawing it like an 8. I've got to do my 2 circles. It's so much better when I do it that way. That would be infinity, and actually infinity, that would actually be positive. And then if I have a negative sign in front of it, then that will be negative infinity. So those are some symbols that we're about to use. And then we always describe graphs including end behavior from left to right. The X determines the value, or the order, sorry. The X determines the order. Okay, left to right is the X. That's going to determine what order we write these. So I'm going to go to our first example where the leading degree is even and positive. Oh, sorry, I said it wrong. The degree is even and the leading coefficient is positive. We're going to start talking about the Y value approaching what as our X value approaches something else. Now, what I said is we always go from left to right. We always go from left to right. So I'm going to look at the left side first. And I'm going to start with the X value. X is approaching which infinity on the left side? So you think about X. X going this direction is negative infinity. Then we're going to fill in the Y value, which is up and down. So it looks like we're going up, which is going to be positive infinity. So for the left side, the Y values are going up while the X values get smaller. As X's go to negative infinity, the Y's are going higher and higher and higher and higher. So we normally don't read the graph going towards negative infinity, but that's what we're doing for end behavior. Then there's a second part. We now have to talk about the right side. Let me change the color of the right side. Let's do the right side in blue. It's probably too close to purple. So here's the right side of the graph. And we start out with f of x is approaching. Now we look here and you see that your f of x is going up. So that's positive infinity. As your x is approaching, now the x's are going to the right. So that is positive infinity. So as x goes to negative infinity, as x goes to positive infinity, that remains the same for every single one of these. Left, then right, should be in that order, then the x's will remain the same the whole time. So let me write the next one. So we're going to start with f of x is approaching. Now I'm looking on the left side. It's going down, so negative infinity. As x is approaching, now every single time x on the left side is going to be approaching negative infinity. Every single time. Then we've got f of x. Now we're going to do the right side. F of x approaches, so we go to the right side. And to the right side, it's going up. So positive infinity. As x, and this is going left, so that will be positive infinity. And you'll notice that my x's and what they approach is exactly the same as the first one. And it will be the same every single time. So if the degree is even and leading coefficient is negative, f of x, so we're going to start with our left, is going down. So negative infinity. As the x values, so we think on the left, x's are going to negative infinity. I guess I could write this here. So x's are going to negative infinity. And then f of x approaches, so on the right side, f of x is also going down to negative infinity as x is going to positive infinity. And then the last one, so I'm going to start with the left. And I actually think this is helpful to put these in. I wasn't thinking about it earlier. I'm going to start with the left, and the f of x is going up, so positive infinity, as x is always going to negative infinity on the left. And then on the right side, f of x approaches, and this time it's going down, so negative infinity, as x is approaching positive infinity on the right. So those are the only 4 situations that you'll have. You really just memorize the x values, and then the y's are the thing that changes. So here's 2 examples. We're going to describe the end behavior. So if I look at the first one, I have to find the degree. And the degree is the highest exponent in the terms. So I'm looking at my terms. My highest exponent is not the first one. Looks like this is not in the order that I would typically write my trinomial. So when I reorder that, this is my first term, and my degree is 3. And that is odd. And then my leading coefficient is -2, which is negative. So when I think of odd, I think of lines, but the negative, that means that it has to go the other direction. So I'm trying to find end behavior that's like this. I have no idea what's going on in the inside. All I know is that's the end behavior. So I'm going to start with f of x, and I'm going to start with the left side. F of x is going up, approaches positive infinity, as x approaches negative infinity, because it always does on the left. And then the right side, f of x approaches, and we look on the right, and it's going down, so negative infinity. As the x values, since they're going to the right, they go to positive infinity. Okay, question B. Is this one in the correct order? Not exactly, but it doesn't really affect my answer. This would be a 32/7 x cubed next, then minus 5x squared plus 1. So that would be the correct order, but I just need my first term. So my degree is 6, which is even. And my leading coefficient is 4, which is positive. So I think about the even that I know the most. When it's positive, it looks like this. This is not a quadratic, so don't know what's going on the inside. I just know that the ends are going to look like that. So we will write our left side first. F of x approaches positive infinity as the x goes to the left, negative infinity. And then our right side, f of x approaches positive infinity as our x value is approaching positive infinity because it's on the right. The fundamental theorem of algebra, every polynomial of degree greater than 0 with complex coefficients has at least one linear factor. So a linear factor is going to be a factor that by itself, if you just graphed it by itself, it would be a line. A linear factor could be like 2x plus 3. A linear factor could be x minus 9. It's going to have x to the first power. Oh, a linear factor could be 3x. A linear factor could just be x. Could be x squared, but then nope, that wouldn't be a linear factor. Just kidding. So anyway, has at least one linear factor. These are all linear factors. And then linear factorization theorem would be that every polynomial of degree n is greater than 0 with complex coefficients can be factored into exactly n linear factors. So if the degree is n, that's how many factors we will have when we are done factoring it. So here I'm looking at the number of factors, and there's 3 factors. There's 3 linear factors. That tells me my degree is 3, which is odd. We're going to find the zeros and any multiplicity. So finding the zeros is when you plug 0 in for y, or in this case, p of x. And then we're going to set each factor equal to 0. We're going to solve for each factor. And I am going to put the zeros in order from left to right, from smallest to greatest. So -3, then -1, then 2. And there is no multiplicity. Multiplicity would be if some of these answers happened more than once. But we're going to see that in the next question. So I'm going to start with the number of linear factors we have here. We've got 4. We've got x plus 7 squared. So that means x plus 7 and x plus 7. We've got x minus 3, x minus 3, and x minus 3. So we've got 6 factors, but we only have 5 linear factors. Unfortunately, 4 would be like 4 with an x to the 0 on it, which does not qualify us for a linear factor. So the linear factors would have to have the x to the first power. We've got 5 of those. So this would be a degree of 5, which is odd. And I'm doing this because you're going to have to do it in your assignment. That didn't ask me to do it for this question, but it's to help us understand what you're doing in your assignment. Now I'm going to set factors equal to 0. I'm going to do x plus 7 equals 0. I'm going to do x minus 3 equals 0, but I have no reason to do 4 equals 0 because there's no x in it. There's nothing to solve. So x equals -7 and x equals 3. So those would be my zeros. And I forgot to put the 0 here. Those would be my zeros. Now, about multiplicity, how many factors had -7 as an answer? So -7 has a multiplicity. I forgot my T. Multiplicity of 2. And 3 has a multiplicity of 3, because that factor happened 3 times. Oh. Okay, next example. I'm going to go ahead and put a 0 in here. I'm going to factor x squared minus 7x plus 12, because that's going to be x minus 3 and x minus 4. And since there's a squared on the outside, that means we're going to have 2 of each of these squared. So I'm going to set each factor equal to 0. And I get my zeros at 3 and 4. So those are my zeros. Now we're going to write about their multiplicity. 3 has a multiplicity of 2, and 4 has a multiplicity of 2. Both of them were squared. Right, this next one, I'm going to start factoring it, and we always look for a greatest common factor first. And I can factor it further. And now we have it factored. X squared is not a linear factor, but x and x separately are, so that's okay the way that it's written. X equals 0, x minus 5 equals 0, x plus 4 equals 0. So we get 0, 5, and negative 4. Oops. Negative 4. I'll write those zeros down. In order, that'll be negative 4, then 0, then 5. And then we look for any multiplicity, and 0 has a multiplicity. So 0 has a multiplicity of 2. All right, the last one is a factor by grouping. When you do factor by grouping, remember you have to make an addition sign in between the 2. So I did plus negative first. Let's see, I'm going to factor out an x squared. This one I'm going to factor out a negative 25. So x squared times x minus 4 plus, I factor out that negative 25, and I'm going to be left over with x minus 4. So at this time, we now have like 2 terms. We've binomials, and we're going to divide by the thing they have in common. And I don't mean divide, I mean factor out that thing they have in common and put that in front. And then what's left, x squared minus 25, gets to be in the other parenthesis. I forgot to make this a 0, so there you go. I made it a 0. Now, x squared minus 25 can be factored further. It is a difference of squares. And I'm going to set each factor equal to 0. I'll just change back to pink now. And so we get our zeros at, see, the first one would be negative 5, then 4, then positive 5. And do we have any multiplicity? I did not see any repeating values. I look up here, the degree of the original question. The degree is a 3. And we have 1, 2, 3 solutions, so I'm not missing anything. Okay, this intermediate value theorem, you know what, I'm going to go to it last. I'm going to go to it last. Okay, example 4, find the polynomial function with the given zeros and multiplicity. So let's call it f of x. Nope, I'm going to leave some space. With the given zeros, we're going to have a 0. We're going to have x equals 0. And there's a multiplicity of 2. And then we've got x equals -3. So I'm going to write that as a factor. I need to make it say equals 0. This one already does. So x is the factor. This one I'll have to do x plus 3 equals 0. So x plus 3 is the factor. So we're going to have f of x equals x multiplied by x plus 3. Now, 0 with a multiplicity of 2 means the the factor that gave us 0 has to be squared. So if you could also think about it, there being 2 of these, and they would multiply back together. X times x is x squared. So this one we've got x equals -2. I've got x equals 6/7. And I've got x equals 4/3. For this one, I've got, let's see, add the 2. So x plus 2 equals 0. Now, these are a little bit trickier. When we have fractions, we want to get rid of the denominator first. We're going to make them not fractions. So I get 7x equals 6. Now subtract the 6. I get 7x minus 6 equals 0. Do the same thing for 4/3. I'm going to multiply both sides by 3. So I get 3x equals 4. Subtract the 4. 3x minus 4 equals 0. Now it says nothing about multiplicity. So f of x, we're just going to have x plus 2, 7x minus 6, and 3x minus 4. Find a polynomial of degree n that has the given zeros. So here is our 0 of x equals 9. So I'm going to find the 0 as a factor. I'm going to subtract the 9. I get x minus 9 equals 0. So we get f of x equals x minus 9. Currently, that degree is just 1 because there were only one solution. So in order to make it a degree of 3, we need to have 3 of those same solutions. We need to have a multiplicity of 3. We could not add a different factor here because it only has the 1 0. Here we've got zeros at -2, at 0, and at 1/3. That's 3 zeros, but our degree is 5. So somehow we're going to have some multiplicity. Oopsies. So I have x equals -2. So x plus 2 equals 0. I have x equals 0. And then x equals 1/3, which I have to multiply by 3. So 3x equals 1. So 3x minus 1 equals 0. Got f of x equals, we could have x times x plus 2 squared times 3x minus 1 squared. Or we could have x to the 3rd times x plus 2 times 3x minus 1. That would give us 5. Or we could have x squared times x plus 2 squared times 3x minus 1. That would give us 5. Oops. And this last one would also give us 5. So all of those would be valid answers. This next one says a degree of 4, and we have 3 different zeros. So we've got x equals 0, We've got x equals square root 2, and we've got x equals negative square root 2. So I solve them for 0. We've got x and x minus square root 2 and x plus square root 2. And these are linear factors, but we have a degree of 4. So we've got to have 2 of one of them. This really is our only option in order for this to have complex, well, integer terms of it if you multiply it all out, which is usually what we're going to have. That would really be our only situation that we could possibly have. Okay, so that was kind of just giving you like an intro. This is actually more closely to what your assignment will look like. So your assignment's going to start with a given equation, and we're going to start listing things. Leading coefficient. Well, that is positive. The degree. So we've got 2 here, we've got 1 here, and we've got 1 here. So we've got a total of 4, which is even. I meant to write even on that blank. You don't have to write 4. You don't have to have the number. So the end behavior, if we've got positive even, that's going to look like this. It's a lot like a parabola. So we're going to say f of x, this is my left side, approaches positive infinity as x goes to the left, which is negative infinity. And then f of x approaches, so on the right side, we've got positive infinity, as x to the right is going to positive infinity. So there's our end behavior. We're going to factor and find the zeros. Well, it's actually kind of factored. We're just going to find the zeros. Oh, geez. Once I get this lined up. Okay, so I'm going to start with 1/2 x squared. I'm going to have negative x minus 4 equals 0. And 2x minus 3 equals 0. So we're finding the zeros. I'm going to divide by half. And then I've got x equals 0 for this one. But this has a multiplicity of 2. Here I'm going to add the 4. So I get negative x equals 4. So x is negative 4. And then for this one, we're going to add the 3. Divide by 2. X equals 3 over 2. We're going to write our answers as x equals fancy bracket, and we're going to go from lowest to greatest, from least to greatest. Negative 4, 0, 3 over 2. Y-intercept. To find the y-intercept, we plug 0 in for x. Solve for y. So in my original question, we had 1/2 x squared, so 0 squared, multiplied by negative 0 minus 4, multiplied by, what was it, 2 times 0 minus 3. And this is what, negative 4. It actually doesn't matter. This is negative 3, but this is 0. So if I'm multiplying everything by 0, this is going to be 0. Relative extrema. So this you're going to need your calculator for. Let me see if there's anything else before I grab my calculator. Okay, so there's nothing else before I grab my calculator. So what I'm going to do is I'm going to, see if I can plug in my camera so you can see what I'm doing on the calculator. Maybe. Yeah, you are going to have to excuse the fact that I have a million things on my desk. That's for sure. Okay. Let's maybe give it a little bit of light. My room's pretty dark too. Okay, hopefully that's not too much light. Let's that might be too much. Let's try it without the light. Sorry, I should have figured this out beforehand. That would have been helpful, wouldn't it? That would have been helpful. Okay, I'm going to turn a different light on. Ow. Okay, we're going to go to y equals, oh gosh, can't see that very well. Okay, so I guess you're going to see my screen really well, but not so much my buttons. All right, I need the equation, which of course is on the other page. I definitely should have set this up ahead of time. I apologize, guys. All right, let me type this equation in. Oops. All right, I typed the equation in. I hit Zoom 6 just to make sure that my window was okay. And this is the graph that I got. Now what we have to do is we have to find the relative minimum and relative maximum. So the extremes. So this is the end behavior. They're both going down. That is not the correct graph. I typed it in wrong. One moment. Oh no, I did type it in right. Oh, this is a good thing. So I figured something out wrong when I was doing it. Now we got to go back here and figure out I know what I did wrong now that I'm thinking about it, but I wasn't thinking about it a moment ago. Okay, when we were figuring out the leading coefficient being positive or negative, I was just looking here and that was a mistake. I really need to look here and here because all of those will end up being multiplied together if we multiplied them all out. And I've got a positive and I've got a negative and I've got a positive. And if I multiply those together, I'm going to end up with a negative. So I'm going to have a negative. So that means that my graph should be opening down and down. So that means that my end behavior is incorrect. The end behavior should be negative infinity for both of these. Now it does not affect my x's, but it affects my y's. And you guys see how I just did all these corrections on my work? That's the kind of corrections I should see on your work too. All right, going back down here for the relative extrema. Here we go, relative extrema. So what you want to do on your calculator is we want to find any minimum point and any maximum point. And up here, there's going to be another maximum point. The only way we're going to be able to find minimum and maximum points is using the calc button, which is second trace. So that you probably could not see me push, barely. You could see my finger right there, second trace. We are going to do minimum or maximum. So let me start with the middle one was a minimum, number 3. Okay, then it says left boundary. We need to pick something that's to the left of this middle point, which I think that point's 0, 0. So to the left of it could be -1. I'm going to type in -1, enter. Then right, I'm going to type in 1, enter. Now guess, I think it says 0. And it tells me the minimum is at 0, 0. So in my assignment, I'm going to write, I'm going to change my color because I ran out of space over there. Minimum 0, 0. Okay, the other two on the graph have got to be maximums. This one up here and that one way up there. So let's try to do that maximum without changing the graph. Second trace, maximum, number 4. And so that maximum, I'm not sure exactly where it is, but I need something to the left of it. Well, I know 1, 2, 3, 4, 5's definitely to the left of it. So I'm going to type in -5, enter. Now to the right of it, well, I know 0's to the right of it. 1 is probably to the right of it, so -1. I'll go with that one. And it shows these 2 lines, and then it says guess. I really have no idea. Maybe 2, maybe 3. I'll go with 2. -2, I mean. It does not have to be perfect for the guess. And now we have a terrible looking maximum, but we'll round to 3 decimal places and call that our maximum. So, what am I on? This one. So we'll have a max at -2.907, comma 40.705 or 706. Okay, so that's one of our maximums. We're going to do the same thing again with the other maximum. Choose number 4. Do the left bound. So 0 could be the left of it, and to the right of it would be 2. And I'm going to guess 1. And it's not exactly 1. Oh, I'm sorry. I didn't show you that part on the... I'm sorry. I'll do it again. Second trace, maximum 4. And so my left bound, I'm going to guess 0, enter. And for my right bound, I'm going to guess 2, enter. And then I'm going to look in between there and see it kind of looks like at 1. But it tells me it's not exactly at 1. It tells me it's at 1.032. So I'm going to write down that on my answer. 1.032, comma 2.508. Now the last thing you're going to do is you're going to graph these graphs. And let's see, things that can definitely be accurate on this graph are zeros. Got a 0 at -4. We have a 0 at 0 and a 0 at 1.5. Okay, we can look at our, what was our y-intercept? Oh, our y-intercept was 0 also. We already have that graphed. We look at our maximums and our minimums, and it looks like the highest number we have is 40. It's 40.7, so maybe I'll make my graph count by 4s. Now notice I did not do that for my x-axis. You can totally have your x and your y-axis be different. So if I'm counting by 4s, this one up here is going to be 40. And you just need to label a couple numbers. You don't have to label the whole thing. And then what was it? Negative 2.9 and then just over 40. 2.9 and then just over 40. So maybe about there. Doesn't have to be 100% accurate. We're just going to do the best that we can. And then the other maximum was at 1 and then about 2.5. Oops, I forgot my scale. This is 4, so 2.5 would be about here. And then we have a minimum right here at 0, 0. We've got a maximum way up here. So we're going to do our best to connect those and draw it. Okay, I was not happy with what I just did. I'm going to redo that real fast. Still not 100% accurate. That was a little bit better. Okay. So that's approximately what our graph would look like. And that's what I want you to do. I want you to find the maximum, minimum, graph those, the y-intercept, graph it, the x-intercepts, graph it. Think about your end behavior. This is opening down. You saw that I got that wrong at first, but once I looked at the graph, then I was like, oh, that's why it's that way. All right, I am, of course, going to work through the next example, but at any point, if this video is getting way too long, you can pause it and just like answer the questions yourself. You don't have to have me walk you through every single question. I'm right now just typing this next equation in so that when I get to that part on the calculator, it's ready to go. Okay, leading coefficient. This time I know we're going to check all of these here. And those are all ones. And we've got a negative, we've got a positive 1/20th. So we got all positives. This is positive. Our degree, we've got no x's out here. We've got a power of 3. We've got a power of 2. And we've got a power of 2. That's going to give me 7. Our degree is odd. Our end behavior, and this is all stuff that you should be able to do before looking at the calculator. You do get to look at the calculator to fix it, but all of this is before looking at the calculator. You will have a quiz at some point that part of it's non-calculator, and this would be on the non-calculator portion. Okay, so if I add 3 plus 2 plus 2 equals 7, that's odd. Positive, it's going to end up like this. So end behavior, f of x, approaches negative infinity as x goes to the left, negative infinity. And then f of x approaches positive infinity as x to the right goes to positive infinity. This one says factor and find all zeros. It's already factored for us. We just need to find all the zeros. So we've got x plus 4, x minus 1, and x minus 3. And you notice that I have yet to use my calculator for this part. So we've got our zeros at, in order, negative 4, then 1, then 3. Now, if we were talking about multiplicity, there would be a multiplicity of 3 of those. There would be a multiplicity of 2 of those. And there would be a multiplicity of 2 of those. Find my zero. Sorry. Apparently those zeros were going on this blank. The y-intercept. So the y-intercept, the x is going to be 0. So we got to plug in and find what the y-intercept is going to be. So I'm going to have 1/20th times 0 plus 4 to the third times 0 minus 1 squared times 0 minus 3 squared. So that'll be 1/2. 4 to the third is 64. Negative 1 squared is 1. And then negative 3 squared is 9. I'm going to do 1/2 of 64 first, which is 32 times 9. So 288. So as soon as I graph this, I know the graph is going to go up pretty high if the y-intercept is at 288. So now I'll take it over to my graph. And I went ahead and graphed it. Definitely cannot see everything. If you want to see different things, you can always go to your window, which is the button right here that says window, and maybe our x minimum, what did it look like before? Really, it doesn't go that far. Like, it doesn't have anything happening down here, so maybe x minimum just, we'll just keep it at -10. And then maximum, it's got to be at least 300. Let's try 500. I really have no idea. I haven't done this problem since last year. So, and I'll say for my scale, I'll say I'm just going to count by tens. That's probably too small, but we'll find out. Maybe we should make our, nah, I'm getting carried away. All right, our y min and our y max, I'm gonna leave that the same. And let's see what the graph looks like now. Ooh, that was terrible. What did I do wrong? X min, oh, I changed the x's. I meant to change the y's. That was what I did wrong. Let's try that again. I want to change the up and the down. I'm tired. I'm sorry. Let's change the y minimum. Well, keep the y minimum there, and we'll change the y maximum to 510. And I'm going to count by 50s. There we go. Now I'm happy. Okay, I think I made 500 just maybe way too big, so I'm going to go back to the window. And let's say 310 instead. Okay. Gosh, I could have gone way lower. So now I'm a little worried because I got 288 for my... Oh no. Of course my hover cam stopped working. You know what? We're just gonna have to use Desmos. Sorry guys. Of course now this is gonna be a longer video because my hover cam doesn't work. Maybe I could have used Desmos. Well, I couldn't use Desmos because I got to show you how to graph the stuff. Now that I'm gonna have to. Okay, so there's the equation again. And changing the window on the calculator would be like changing the wrench for this here. I think I went from -10 to 300 or something. Okay, so here's the thing that I was trying to say before. I have the y-intercept wrong. Oh, I know why I have it wrong. I forgot to multiply by the 1/20th. No, 1/2, 1/2, 1/20th. It's 1/20th, right? I don't think I copied it right. It's 1/20th. I forgot to multiply this by the 1/20th. $144, that's still not the right answer. What did I miss? Oh, I did multiply. Oh, okay. I got to go back now. Sorry. So I did multiply it by 1/2. I meant to multiply it by 1/20th when I did the 64. That's what happened there. Okay, so let me go back in time here. 1/20th of 64 would be like 64/20ths multiplied by 9. See, 64 and is divisible by 4, so I've got a 5 here. 16 times 9 is 144 over 5, I believe. Just going to double check that. Yeah, and then that is 28.8. 28.8. Sorry for that mistake. If you caught that mistake earlier, give yourself a gold star. Oh my gosh. So 28.8, not 288. Going back to Desmos, this is what you should have on your graphing calculator as well. Looks like I probably didn't even need to go all the way up to 300. What you want to do now is you want to use your graphing calculator to try to find the minimum and the maximum values. We will have a maximum value right around here. It looks like it might be right at 100, but you'd have to use your calculator to find that. Then it looks like a minimum here at 1. Looks like a maximum somewhere in between. I don't think it's exactly at 2. And then we have a minimum here at 3. And then this right here is not a min or a max. This is called a point of inflection, but it is not a minimum or a maximum, so you wouldn't write that guy down. And I don't think you can find all your minimum and max. Oh, no, you can find them all in Desmos. But this is not the way that you want to do it because you don't get Desmos for a quiz or a test. So that would be my minimum and maximum values. You need to know how to do it on your calculator. All right, we are getting through this. We're almost done, I promise. Oops, if I can find where I was. Here I am. So I just did this on Desmos for time and hovercam quit. Okay, so then you would go and you would graph it, and I'm not going to go over the examples of graphing. I mean, like x-intercepts, the zeros, -4, 1, 3. I didn't write down all the zeros. The y-intercept would be at 28.8. Ooh, what is the highest zero on here though? Looks like almost 100, so it's not quite 100. So maybe we want to count by tens. There you go. Now everybody knows I'm counting by tens. I'm not going to label my x-axis because I'm keeping those the same. All right, 2 more quick sections. The next section is to write the equation in factored form with the given graph. And what you're going to do to write it in factored form is you're going to look for your x-intercepts first. X-intercept, 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 x-intercept. Now, the x-intercepts are at -2, -1, 2, and 3. The end behavior is down to up. So it's got to be odd, and it's got to be positive. Has to be odd and has to be positive. So I start with my x equals -2, my x equals -1, my x equals 2, and my x equals 3. And I'm going to set those so they all say 0. And we've got f of x equals x plus 2, x plus 1, x minus 2, x minus 3. Now, I wrote these in the order from left to right, and when you do things like this on Canvas, that's the order you're going to follow. Just FYI. This gives me a degree of 4. So something's wrong because I need an odd degree. So I'm going to go back to the graph. And something that you should have talked about in Algebra 2, we kind of skipped over a little bit. Actually, probably should have talked about it in this example, and then I never got the graph for this example, so I will go to Desmos and talk about it on the graph, is multiplicity. So at -4, oopsies, -4, the graph had a multiplicity of 3. At -4, there was a multiplicity of 3. You will notice that this graph passes through just like a cubic graph. When I zoom in on just this part of the graph by itself, it looks like a cubic graph. If I'm zoomed in just on this piece that passes through the x-axis, it looks like a cubic graph. Well, that's because there's 3 of those -4s. When I go over to 1, right here, my 0 of 1, it almost looks like, if we zoom in so I can't see anything else going on, it almost looks like a little parabola in here. And that's because x minus 1 is squared. There's 2 values for it. Then we go to the third one, x minus 3, that one's squared. And when we look at that 3, it makes a little parabola. So anytime we have a squared, it's not going to pass through the x-intercept. It's going to bounce off and look like a parabola. Now, on that first example, we did graph. The 0 had a multiplicity of 2, so you can see that forming a parabola. But the -4 only had a multiplicity of 1, and it just went straight through. The 3/2 multiplicity of 1 went straight through. So it made kind of like a line when we zoom in right here. So when I zoom in on each of these, you should notice that one of them has a mini little parabola on it. So that one has a relative min. That is telling me that this has a multiplicity of 2. Sorry, 2. That's telling me this has a multiplicity of 2. So if over in my answer, this one has to be squared. And when it's squared, now we have our degree of 5, which is odd, and it matches the graph. Okay, this one here, we've got -2, and it passes straight through it, so there should only be one, x equals -2. And then over here, looks like we've got 1, 2, 3, and this has a cubic shape. So I'm thinking that at x equals 3, there might be a multiplicity of 3. So looking at end behavior of this graph, it's down, down, and that means negative, but they're going the same direction, so that means even. So if I have x plus 2 and x minus 3 to the third, those two together would make 4 total x's, and then this would be even. Now that does not make negative, so possibly I want to just put a negative sign right in front, and now we have negative. Trying to remember if I actually found the number here. I don't know that this is enough information to find that number. Okay. There's one last thing that we did not cover, and it is last, and it's really, really simple and short. It's called the intermediate value theorem, and you will have this on a quiz, and I will have to use my calculator on the computer since the other one stopped, the video stopped working. I'm going to find it. Where is it on my computer? Here it is. Okay, so for this guy, I need the equation 3x cubed plus 4x squared. We're going to go to y equals 3x cubed. Oopsies, why did it do that? There we go. Plus 4. That's why. 4x. Oh no. I hate using the computer one too. Okay, 3x squared plus 4x, oh, sorry, 3x cubed plus 4x squared minus 9x plus 1. Okay. Now, what we're going to do for the intermediate value theorem is we're going to go to the table. So we're going to do second graph, and we're going to look at our table. And if your table isn't exactly the same as mine, you can scroll up and down using your arrow. You can also set your table up however you want. You can do second window, which is table set. You can tell it what number to start at. So if I want to start at -10, and then you can tell it what, oops, sorry, I can't type negative on the keyboard. There we go, -10. And then this triangle table means the difference in the table. So if I start at -10 and I'm going up by 1, then I'll go to -9, -8, but you could go up by 0.5s if you want. But we don't need that for this one. So I'm going to go back to second graph, and I have my table. See how it starts at -10. And what I'm going to do in my table is I'm going to look at the values on the y side, and I'm going to find where there is a sign change. So from -17 to 11, that is a sign change. So what the intermediate value theorem is asking, between which integers does the sign change happen on the y? So we're asking which x integers does the sign change happen? So we're looking for a range, and it's got to be from -3 to -2. So on my notes, and what you would do in your answer would be -3, -2 will be a sign change. That's guaranteed to have a 0 in there because it goes from the y values being negative to the y values being positive. So it's somewhere in here, the y's have to equal 0. Okay, now we're going to look to see if there's any other sign changes. Oh, here's a sign change where it went positive to negative. So the x's are from 0 to 1. So we're guaranteed to have a 0 in between 0 and 1. Let's see if there's any more. Yep. From -1 to 23 on the y's. That changes signs. So from 1 to 2 on the x's. Be our next one. And then this is a degree of 3, and I just found intervals for 3 zeros, so I know I can't find any else others. Sometimes you won't be able to find as many. You'll never find more. Sometimes you won't find as many intervals as there are zeros, because sometimes I don't know, if you had a graph that was like, here's a 1 and here's a 2, you could possibly have a graph that was like do 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 do, and then there's 1, 2, 3, 4 zeros in between that same interval, because we're only looking at integers from 1 to 2. So you would have no idea by just looking at the table how many zeros were in there. All right, I know this is a long one, but usually we do it in 2 days, so this is the only one that you have for today. Definitely communicate with me if you have any trouble, and when you start working on it, reach out when you need help. I hope to hear from you guys soon. Bye.